Hi everyone, welcome back to the second half of this lecture. So in this part, we'll learn how to control the lookings or the aesthetics, this word here, of the Seaborn plots. So one of the biggest advantage of Seaborn over Matplotlib is that its default styles are visibly far more appealing. It is no doubt that Matplotlib is highly customizable, but sometimes it may get difficult to know exact settings in order to achieve an attractive plot. Whereas Seaborn comes with a number of customized themes and a high-level interface for controlling the look of the same Matplotlib figures. So Seaborn splits Matplotlib parameters into two independent groups. First group sets the aesthetic style of the plot, and the second scales various elements of the figure to get easily incorporated into different contents. So the first one is the style, and the second group is the scale. So Seaborn doesn't take away any of Matplotlib credits, but rather adds some nice default aesthetics and built-in plots that complement and sometimes replace the complicated Matplotlib code professionals need to write. So this plot cut visit plots and regression plots are an example of this. So in this lecture, we'll be seeing how easy it is to build a regression plot using Seaborn, and then let us compare it by building something similar in Matplotlib. Okay, so the first step is always to loading our intrinsic libraries or modules. So right now we need 4 of them. So NumPy, which is using the arrays, and then pandas to deal with the data frames, and also our Matplotlib and Seaborn. So once we have imported necessary libraries or modules, let us begin talking about the aesthetics within these 2 special lines of code we have added in our previous lecture, part 1. So our first line of the code is this one here. So Matplotlib inline. So this specific statements here is one of the magic function of Jupyter Notebook that along with inline. To the inline backend with a Jupyter Notebook. So if we look into the relevant document, it says, so IPython, which just has the magical functions, has a set of predefined magic functions that you can call with a command line style syntax. So there are 2 kinds of magics, line-oriented and cell-oriented. So these are 2 2 styles of magic functions here. So line magics are prefixed with the percentage character, and works much like OS command line calls. They get as an argument the rest of a line, where the arguments are passed without parentheses or quotes. So right here is called the parameter parts. And line magics can return results and can be used in the right-hand side of any assignments. And cell magics, on the contrary, are prefixed with a double sign. And there are functions that get as an argument not only the rest of the line, but also the lines below it in a separate argument. And with this backend, the output of plotting commands is displayed inline within frontends, like the Jupyter Notebook, directly below the code cell that preceded. The resulting plots will then also be stored in the notebook document. So let us now move on to our second line of code, which is this part here. So the Seaborn runs on top of Matplotlib, and with that as a default, come with a white background for each of our plots because it is what the default of Matplotlib is. And that looks pretty, not that pretty, So with this line of code, we switch our plot to Seaborn default using .set function. And let us look into what else using one of the building data sets. In this data set, we'll use the tips. And so we can generate a bar plot, which is here. So quick note that, so this SNS.set needs to be explicitly called only in Seaborn with 0.8 and above. So we can just call in once here, and then we're going to load in our data sets. We're going to generate the bar plot. So with both of the lines of the code explained above, let us now look into what else can we do to vary the appearance of our plot. Earlier, we spoke about Seaborn segregating matplotlib parameters into two independent groups. So there's styling and the scaling of the figures. So now let's get into the first part, which is the styling part. So let us first begin by devolving into the styling aspect that is controlled by using SNS.accessStyle function and SNS.setStyle function. Alright, so let's begin with the set style. Right here, we use the white grid, and then we're going to generate a box plot. So remember, for any box plot, just like a quick review for you guys. So we have what the parts. So this one here is the median, and this is the upper quantile. This part is the lower quantile. We have the maximum value, we have the minimum value, and these dots, either it can be like a shape, like a dotted shape or a diamond shape. Here's are the outliers. So we have like these 4 categories or 4 days of data. They all have outliers. Okay, so let's get back into our Seaborn. So few common background options include white gray, which is this parameter here that we passed, or dark, so that's a solid green color, or a white, so this is default, and text. And then, so let us explore an example with text as background, and then try to remove top and right axis spines. So noticing that we pass the text arguments into the setStyle function, and then we generate another box plot. So you may see like what's the difference between these. So remember, text or the tickers defining these like small like small lines here, and then in the y-axis as well. So previously we don't have any ticks, and right now we have the ticks in the y-axis as well. So right, just to sum up, in the bar plot we observe 2 changes. There are no horizontal line or grain in the background that we have in the previous plots, because right here the style was set it to be grayed, whether it's going to be like a white grade or a dark grade or something. And then the second one is there are text on both x and y axis. So both in the x and y axis has those tickers or text representing the axis integral. Right. So we still have the top and right axis spine to get rid of. So let's see how do we deal with them. So see, we just set the text style, and then we use a box plot to plot it, and then we use like a dspline function here. Noticing that right here, this one disappears. And if we also want to dspline the left axis, we just need to alter our last line of code by adding the parameter left is equal to true, and it shall fetch for us, right? So left is equal to true, and then we don't have any like spines here for the y-axis. Yep. And now let's try to temporarily visualize 2 kinds of background in a single plot. For this, we shall use the axis style as follows. So this function plots some offsets sine waves, so we don't have to necessarily care too much about it. And then, so say for example, we have the styles, we have the dark gray, which is like this, and then compare with the previous or white gray, which is like this. Okay. Yep. And then we're gonna subplot it. There are 2 in a row. Right. So that's how you can there's 2 types of background in a single plot. Okay, next let's move into our second, which is the scaling part. This scaling part is controlled using .plotting context and .set context functions, so these 2. And there are 4 preset contexts. So in order of relative size are paper, notebook, talk, and poster. So the notebook style is default and what used in the plots above. At first, it set the default parameters by calling SNS.set, and then play around with other contexts for scaling. So we'll start with paper. So we can just try the SNS.set, This is for setting like the styles here. And then we use SNS.set context, which is the paper set. And just using the set style functions for the previous part. We use the white grid, and then we generate a box plot for us. So Jupyter Notebook scales down large images in the notebook cell output. This is generally done because past a certain size, we'll get automatic figure scaling. So for exploratory analysis, we prefer iterating quickly over a number of different analyses, and it's more useful to have first sets that are of the similar size than to have overall figures that are same size in a particular content. So when we're in a situation where we need to have something that's exactly a certain size overall, ideally we'll first know previously what you want, and ideally we can afford to take up some time and work through the calculations. Well, so that being said, if we plot the same figure in an editor like Anaconda Spider, or a JetBrains pie chart, or IntelliJ, so these are three very popular editor or IDEs other than Jupyter Notebook. So we shall be able to visualize them in the original size. Hence, what we need to be our takeaway from scaling segment is that an addition of line of code can fetch the size of the images as per our requirements, and we may experiment accordingly. So in practical world, we also add a dictionary of parameters using RC here to have a finer control over aesthetics. So let's see an example with the same sign plots, a function we defined earlier. So noticing that we're using RC right here, which is the line width. So this can be like a huge and a really bold lines over there. So though our notebook didn't display in large or like a scaled plot, we may notice how in the backend, versus just aka in the memory, it has created a figure as per our instructions. We have fig lions now in our plot because we said like this one here is equal to 5. Font size on axis have thickened because of the font style. Right here, this parameter. And generally, we don't use anything more than that during data analysis, although exceptional scenarios may demand few more parameters as per requirements. And it is also noticing that this magic function, matplotlib inline, just needs to be called only once in a kernel, unless we refresh or restart the kernel. Then this is the function that works only in Jupyter Notebook, and it's not workable in other IDEs like Spider or PyCharm. And also, style and context, what sets remain defined unless we explicitly call for a change. So if never caught in a kernel, Seaborn will work with its defaults, which is the matplotlib white background without grades and notebook scale size. So basically here for today's lecture, the takeaways from that is we comparing how easy to customize the aesthetics or the appealing of the graphs using Seaborn versus as using matplotlib. So the Seaborn got two independent groups. The first group sets the style, and the second group sets the scales. So there are two functions in this, styling sets, which is the SNS style axis style and SNS style set style. And there are other two functions in our scaling part, which is the plotting context and the set context function. Yep, and also there are two lines that for us to be able to use the Seaborn correctly. The first one is the magic function, or we can categorize like line magic functions right here. And the other one is SNS.set, which just defaults come with the Seaborn defaults options. So that's the only the takeaways for today's lecture, and I hope you guys enjoy it, and I will see you guys in the next couple of lectures.